last talk of this practice talk session. And the topic is process mining metrics, right? And it's about performance measurement. We heard a lot about KPIs, measuring processes. And well, I realize it's first of all the end of the day, and I'm not sure how many of you are really like, yay, metrics, I want to know more about metrics. It's a little bit of a dry topic, I realize that, but it's a very important topic. So what I decided to do is to reward you a little bit for sticking with me for the next half hour. I'll throw in a couple of, for those of you who are bored, a couple of cute animal pictures to lose it up a little. So let's get started. Why do we need metrics in the first place? Why do we need them? And we have heard a lot about that also earlier today. It's really, a metric is a standard for measuring something or evaluating something. So we want to evaluate a process. Is it doing well or is it not doing well? And we may need to compare different processes. Is this process performing better than the other one? Or, is this process now performing better than before? So it's all about getting that quantification in our process analysis. And there are different areas where that plays a role. So that's just another way of looking at that typical Lean Six Sigma methodology, which is called DMAIC, where you have these 5 phases, right? Define, measure, analyze. That's what you're doing in the beginning of the as-is process. And then the actual improvement happens, so you're actually changing the process, doing, change initiative in the organization to reduce cost, improve quality, whatever the goal of the improvement project is. And then in the end, hopefully you arrive at the process that you want to arrive at. And then you still have to make sure that you actually achieve the effect that you wanted to. So especially in those analyze and control phases, this is where a lot of those metrics and the actual quantification of measuring your process really comes into play. And a second view is just basically a different way to look at that. It's this management technique, which is called plan, do, check, act, which we have seen before also a couple of times. Also here, you're doing it in a continuous way, and you have to look at the planning and the check phases if you want to do the performance measurements. And one interesting addition to that, even before you're going into a concrete improvement, either a concrete continuous improvement cycle or a concrete improvement project, I've had the question from one of our customers who has a workflow systems with literally hundreds or I think even thousands of different processes in it. Well, where do I start? It's more of a benchmarking idea before even going into the detailed analysis, which is the most kind of severe place, and how can I maybe make the selection in the right way that I get the biggest impact. So then from that place there comes a desire to have some kind of, maybe they call it like a health check or some health metric or something, where they would maybe combine different factors to find out, well, I should start here and start analyzing that. So even before you're going into the improvement, you want to do that. The problem is that with metrics and with quantifying things, there also come a couple of problems. And one of the first problems is that it feels very objective, right? We have a number, we have a fixed percentage or something, and that may be misleading. So people sometimes attach too much objectivity or meaning to that kind of number, right? It must be true. Well, there can be a lot of problems. So to illustrate that, I really like those examples of, there's a book about it, it's called, I think, Spur's Correlations, where they basically look at completely unrelated things, and they calculate how correlated they are. And it turns out they are statistically significantly very much correlated. So there needs to be a relation. So here, for example, you see the US spending on science and technology and suicides by hanging. Well, or this one is really nice, right? So Nicolas Cage really seems to have something to do with it. Just look at that pattern, right? Significantly correlated. Or a third one, well, the divorce rate seems to be correlated to the, consumption rate of margarine. I don't know about that. And the last one, well, non-commercial space launches and sociology doctorates. So you know, if you really look at the pattern, well, that's the thing, statistics, and there's also the saying, lying with statistics. So there's a lot of ways to get some effect or something out, which doesn't mean that it's true because of that. Well, a second challenge that you see is that the metrics that you formulate, especially if you're using them as a KPI in your organization, they have an effect on people as well, right? They influence the behavior of the people, and that can, again, maybe limit the reach that they give, or, you know, also maybe even work counter to what you intended them to do. And a nice example for that is a project that we did some time back at a call center, you know, customer service process, where we were looking at some of the typical metrics, like, for example, first call resolution rate. And these were just the contact methods. So the customer could come into contact with the company in different ways, right? So they could call in through phone. That's what happened 21,000 times. Of course, it's the most dominant one. And then, of course, many of them, you know, 21,000 out of the 21,304 immediately were closed in the first call, and 98%. So great results. But then what turned out is it was actually quite suspicious, because the closure rate for those service requests, they were always, you know, around the same time. So after, at maximum 3 days, the case was closed. So that seemed to be like, well, there seems to be some kind of eager closing going on there. And once we started to look a little bit of a broader approach, look just a little bit wider in terms of time, so to give the customers actually time to call back, maybe a couple of days later. If the issue wasn't resolved, they would call back, and it would be a repeat call, not a new request. But due to the fact that they were measured based on first contact resolution rate, that drives this kind of behavior to just close the case. You get good ratings, you get great KPIs, but actually for the customer, the performance and the experience is worse, because the customer calls and they have to give all their details again. They have to go through the whole process again. While if the case is still open, the agent could reuse the case data, and the customer wouldn't have to provide all that information again. So once you shift that perspective and measure slightly differently, then you see that there weren't actually 21,000 cases in that time frame, but actually just a little bit more than 70,000. And there were a lot of repeat calls, and the first contact resolution rate was just 82%. So that's a second problem of metrics that we have. And a third one is that you, in a way, if you put something in one number, you only see really like the tip of the iceberg. You see a very condensed version of what you're trying to measure or trying to get out of your assessment. But there's a lot of complexity underneath that is hidden and that you don't see. And that can be also a challenge sometimes for people if they have to trust the results. So someone once told me, well, they built a nice dashboard, they showed it to a manager or the CEO or someone in their organization, and they said something like, well, I don't believe this, I don't trust this. So for them it was kind of a black box that came up with numbers at the end. And that's a challenge. So I would say even that for process mining, we have the advantage that we start with the raw data, and that we can really document and really show the steps that happened in between to make it more transparent. So if there's any doubt, you know, how you, for example, came up with this mean case duration of 6 days, well, what is this based on, right? What went into that analysis? That, in the analysis itself, you can always go back and see what kind of assumptions you did. So, for example, in Disco, you would go to the filters, you could see what filters do you have, and you have it documented, and you have that transparency right there. But it still remains a challenge, right? Because you condense everything into this one number. Now, well, so let's say you want to do, measurements. How do you actually ensure that you don't fall into that traps? And what does a good metric look like? What should you pay attention to do good quality measurements for your process statistics? And there are a couple of quality criteria that are known in the literature in different places. For example, software, but also survey quality. So there you get different aspects of dimensions of quality for metrics, and it's basically these four, and they're quite simple. So it's validity, reproducibility, stability, and analyzability. And I'll explain briefly what I mean by that. The first one is clear, right? Validity means there should be a sufficient correlation between the property that you want to measure and the measured value. So that it should be actually measuring. Your metric should be really measuring what you want to measure. So that's like the first thing that you want to have. The second one is already more interesting. It's like the measurement should be repeatable. So that's, of course, a challenge sometimes with more subjective assessments. Then different people, if you ask them at different times, might answer completely differently. You want to have an objectively documented and a reproducible process to derive that metric, to be, to have it as a trustworthy source of decision making. And then the third one is stability. And stability means that it does measure that property that you want to measure. So we have the validity, but it also shouldn't be too much influenced by something else that you're not trying to measure, right? And there can be different aspects of that. I mean, if you just imagine, for example, you try to measure the outside temperature, of the air. You have a thermometer somewhere outside. If you have that placed directly next to a heater, well, that's going to be influenced. That's like a trivial example. But even if you're looking within a certain metric, you may find these kind of problems. So that's nicely shown based on the example of the difference between the mean and the median, right? At the beginning, when we didn't have the median yet in Disco, people were always bugging us, well, you have to add the median. The median is, because, why is that the case? They were completely right about it, because the mean is often heavily influenced by outliers. And I'll have a simple example here where you can see that, in case you're not familiar with it. So we have a number of different values. 1, 2, 3, 4, 5, 6, 7 different values, and we see what the measured value for each of those is. So the first two were measured at 1, the second was measured at 2, the third was measured as 3, the fourth and fifth as well. And then there's 1, so the seventh one is really the extreme outlier here, which was measured at 30. And this could be throughput time in days or something, right? A range of between 1 day in throughput time for the complete process until 30 days. Well, if you would add those up and divide by the number of values with, like you do with the mean, you arrive at 6.14, as a mean case duration. But if you look at those values, actually 6.1 is not like, if you're looking for what's the typical kind of value to expect, it's probably not 6.1, but the median is then working in a different way. Basically, you're just counting the different values, the same number from the right and the same number from the left, and you're picking the middle one. So we are picking the most middle value, and that would be 3. So by doing that, if you have just a few outliers which are extreme, then the median is less susceptible those kind of influences. But it's less appropriate in different situations. So you have to look at what you're trying to measure there. But the difference can be quite big, because if you look, for example, at that process map, then on the left you see the same process with the mean performance. On the right side you have the median performance, and then it directs the analyst much more to really the relevant areas in the process where you have the long delays and waiting times. Now, the last one is analyzability, and analyzability means like what can you do with the value once you have that quantified measure out of your process characteristic. Can you compare it? How does it scale? And there are actually different kind of levels of how analyzable a process metric is. And there's a scale from nominal over ordinal to interval and ratio scale. And I have quick example for that here. So the nominal scale means that you basically cannot do any comparisons at all. So if you have something like yes or no, or red, green, blue, or something, there's no order between things. So that's just the basic level of the nominal scale. If you go one level up, you do have in order. So for example, if you look at those values there, night, dawn, noon, afternoon, evening, it's clear if you would have to put them in a certain sequence, it's clear which sequence it would be. But it's not necessarily the same spacing between them. So yeah, you couldn't say something, how far away they are from each other. Just the order is clear. And then with the interval scale, you do have equal spacing. And examples for that would be, for example, a 12-hour clock, right, from where you count from 0 till 12, and then you start again 0 till 12. So if you have two values that have equal spacing in the, in the morning segment of the day, and it's the same distance in the second half segment of the day, it's going to be the same amount of hours of difference. And also Celsius and Fahrenheit are, interval scales. But what you cannot do with an interval scale is say something like it's twice as X, it's twice as hot, it's twice as fast. It's maybe counterintuitive, but you can't say that 20 degrees Celsius is twice as warm as 10 degrees Celsius. It's not correct, right? And the reason why that's not there is you need an absolute 0 point to be able to say that. So with Kelvin temperature, you could say, you could make statements like it's twice as hot. So the thing that you can take away from that is once you're trying to create your own metric, maybe combining different aspects even into getting, some kind of health check metric or something, you should try to think about those properties and try to get the metric ideally into a range between some kind of, worst value, could be 0, for example, where none of that property is there that you want, up to 100% or 1 or something, where it's maybe the perfect place, and then it should gradually and, in a predictable way move between those values. So that's a bit on the theory of metrics and what you should pay attention to. But now let's look at some, what are typical process-mining metrics, and which kind of questions can you analyze, and what do we see people analyze their processes for, and how do they quantify that? So I'll have a few examples that I'll illustrate, and some more that I just list for your information and inspiration. We will give you the slides in the next days, so you can also look through them and see whether you can use that in some way. Well, the first example that I want to use is the number of steps, and the number of steps is a criterion for process, effort. Basically, every time that someone is, for example, doing something with the process, one step in the process is being performed. And a nice example was there shown last year by, so this is a slide that I copied from Frank van Geffen, that he presented last year at the Process Mining Camp, where they were looking at an incident management process for broken monitors, and they were measuring the number of steps people had to take to solve that incident. So then it turned out that 11 steps was the average, number of steps needed. And then they used that also to look into, do a qualitative root cause analysis. Where is the waste? Where is loopbacks? Where are unnecessary steps happening? And that can be used very effectively in a process improvement project, to do root cause analysis. But if you're looking into measuring things, then after a while, it turned out that this average, number of steps, or you could say median number of steps, wasn't ideal for a number of reasons. And they started to measure it in a slightly different way. Rather than just taking the mean or median, they were looking at, well, how many % of the cases fall into a certain range? And I'll show you why that makes a difference. If we look at, that's just, the sandbox example that we have in Disco of the purchasing process. If you look at the distribution of events per case, then often you have a distribution like that, where in the middle, we have a number of steps. Maybe it's something between 20 and 22 steps or something, that you need to successfully complete the process from the very beginning to the very end. So in a way, that's the ideal number of steps that you need to complete that particular process in terms of effort, in terms of number of steps. Everything that you have that's taking more steps, that means you have rework, you have extra steps, maybe loops. You don't want that, right? But also, and that's the key thing here, you often have much shorter cases as well, which are aborted prematurely. Maybe there were duplicates. Maybe there were early on someone said, "Well, no, we are not going to go through with that," and they're discarded. So they don't have enough steps to basically go through a successful run-through, but they're kind of shortened versions of that. And actually, this is also waste. This is something where you typically are trying to look for, well, can I prevent those cases from being started in the first place? Maybe I could change my purchasing guidelines or something to make sure people know what they can buy before they go into that, and then I have to say no to it. So the thing is, if you're just taking the average or the mean, you're canceling those two out, right? And it's not really reflecting what you want. So for example, the percentage falling in a specific range brings you closer to what you really want to measure. And then you can go even more detailed. For example, looking at, didn't I? No, I'll show it later for another example. Okay, sorry. The next example I wanted to show is variance. So variants are often really interesting for processes because we assume there are just a few variants, just a few ways to perform the process, but in fact, there's much more variation. So one first instinct we might have is to say, well, we count the number of variants, right? So here I have an example, and it's a little bit hard to read, but so we have one data set, it has around 30 variants, so we can read the number of variants there. And we have another data set that has about 10 times as many variants, 300 something. Well, that gives us some information, but it's not really a great way to compare how much variation there is in a process if you just compare the number of variants. And why is that? That's because it depends on how many cases we have in the data set. And if you look for that one, it's kind of extreme. We just have around 50 or so cases here, and just a very small percentage of the complete data set belongs, just 3% belongs to that data set. While on the other side, we have many thousand and more than 90% of the whole data set where these 300 variants belong to. So just the number of variants alone doesn't say something, or not enough. And so there's a better way to measure that, which in this case I actually learned from Mieke, who first told me about it. So they made a simple formula to compare the number of variants to the number of cases that you have. So you get a ratio for that. And so one version to do that, I'll show you here, is basically to relate the number of variants to the number of cases. And then I'll try to put it into a range between 0 and 1, right? Like what I said before, to get this kind of progress. And I'll show you 2 examples how that looks like. For example, let's take the extreme case example. You have 20 unique cases. So you have 20 cases, and each of them follows their own variant, right? So every case is unique. Well, that's the most variation that you can get in a process. So if you fill that in and you calculate the formula, you get 100% variability for that particular metric. It's just one way to do it. If you look at another example here, where you have the same 20 cases, but they all follow 2 specific variants, then you have much less variability. So if we calculate that, we would come out at 10% variability. And now imagine if you don't have 20 cases, but you would have 200 cases, and also these 200 cases would just follow 2 variants. Well, then this number would be going down to 1%, and it would reflect our intuition about it. So if we have so many cases, so few variants, that indicates a even lower variability. So that's on the level of relating the ratio between variance and cases. But yeah, and we can do that for almost all of the metrics. That's why I was confused before. We can go even further and really look at the distribution of things in more detail. And if we do that for variance, for example in Disco, we can see, well, how many variants are covering my 80% cases. For example, in the example above, you have just 20 variants covering 80% of all the cases. Well, here at the bottom you have, in total almost 800, more than 700. But at the same time, if you look at that distribution below in more detail, you will see that there's one dominant variant, which is actually covering I think more than 50% alone by itself, and then there's a long tail of different ones. So if you look then at the distribution shape, and you can derive a lot of more metrics there, it's getting even more detailed. So these are all different examples to look at process metrics. Other examples, I don't have a concrete example for that. In this case, repetitions, right? Number of cases that have rework, top activities causing rework. So these are things that people frequently look at. Case durations, of course, average, mean, or median case durations, or a number of cases that are falling into a certain service level agreement. Often there's a service level agreement, that you have to complete a case in a certain time frame. And that's similar to the number of events, basically. The one more thing that I want to show here is the waiting times as well, because that's a nice example too. You can look at the waiting time in a process map, and often people then go like, well, okay, I learned something, I'm not looking at the mean, I'm going to look at the median here. Okay, so we have the median as the process metric in our bottleneck analysis, and it looks like this particular step there's a lot of waiting time accumulating. However, if we look more closely, then it turns out actually, in terms of frequency, that's not one of the most frequently used paths. There's another path that's much more frequently used, more than 10 times as much, and is relatively close and is also taking very long. So that's why, for example, for bottleneck analysis, it's quite useful to actually use the total duration, which is cumulative. So it really adds up all the waiting times for all the cases together as the leading metric, which then shows you where the high impact and bottleneck areas are. But then you have the problem that these 12 years, or what it is, it doesn't mean very much, right? It's not something that you or your business users could relate to. So that also shows that, and that's a good situation where that's the case, that sometimes you want to combine different metrics together. For example, here you would like to see the median, and it's shown there in smaller font. But you still, your analysis is guided in the right direction, but you still have that information there as well. So you need different metrics together to make an assessment. That's quite often the case. So the last example that I want to show as well is that there are value adding and non-value adding activities. That's something that I see quite frequently that people do also in Lean Six Sigma analysis. And there was an example presented by Tyne, I think 2 or 3 years ago at Process Mining Camp. I will include the link when we send out the slides, where they did exactly that, right? With Process Mining, you can do that in a very powerful way. You look at the process, how it's really happening, and then you look, well, what's expected? What's the activities that that should be there, that I want to have there, and what are the things that should not happen, or if they have to happen, as little as few as possible. So then these are the ones marked with the red cross, and then you can analyze them, go into detail, do root cause analysis for them. And there are different ways to quantify then, how many you have, how many are value adding, how many are not value adding. And just to complete this section about process mining metrics, some more examples that we see that people look at, for example, fallout, so the number of cases that are not reaching a certain point in the process, which is particularly interesting for order processes, right? Imagine an order process or a sign-up process on a website where people just stop and drop out. You want to look at that. Compliance violations. There are so many different ways to look at compliance from a process perspective, segregation of duties, we have heard before, violated SLAs, like a time perspective. There are government mandated times until when the tax office has to respond to a certain complaint that you make to them. So if they don't meet that deadline, that's not just a performance issue, but it's a compliance issue for them. And then we learned that last year, and sometimes, for example, an auditor is even looking at suspiciously short things rather than just things that take a long time. And there are different ways to measure each of these points that I'm mentioning here. Organizational views, handover of work, delays between groups, and so on. Workload over time, unused path, automation opportunities, open case analysis. So these are, some ideas for you to think about and think about it well, how to quantify them properly. Now, to close this talk, I have some 3 more last points to give on your way in that way. And the first one is, and we had it come up a little bit before, and that's something that Rudi, who unfortunately can't be here today because he's sick, he uses that phrase a lot. He says, like, think of the elephant in the room, right? And that's really true. I've seen it myself as well. If you are doing a process-mining analysis with business people who are, unfamiliar what it is, who are not used to that, you can be sure that it's in the back of their mind. Well, what does it mean for me? What does it mean for my own job? Is it, am I at risk here? And that might, keep them busy. So one thing you really have to do is to account for that human element in your process-mining projects, plan it really well, also take them with you about what you're going to do, why you're doing it, what the scope of the analysis is, and that you need their help, and then try to involve them into it and make it, a joint endeavor, because you do need their help for all the business and the domain-specific insights. And so it doesn't help you if they are not participating, because you need their participation. And well, apparently little elephants throw themselves into the mud if they are sad, so that's what happens then. And the last thing, I think, is also quite clear to most of you, but we have heard it at different places here today also. You are not knowing everything. You have the data, and it sometimes feels like, well, I have all the objective information. I have the truth in my hand here. I have the factual data. I have KPIs, really, hard facts. But you don't see everything, and it's like there's a lot of context information around the process, around the data that you do need to take into account to do a good analysis, also to really get to the bottom of it and to make an effect in the organization. Thank you. So we have time for 2-3 questions, maybe. Okay.
Hi, I'm investigating on network protocols, and I want to know if there's a metric for the information gain due to the process model. So I want to know how long do I have to listen till my model is good enough?
I think that's almost a research question. That's a very good question.
Yes,
I'm not sure I understand it 100%, but is it like, I know that in network protocols that you have certain checks, like that if a package is lost and it doesn't come back, is it about these kind of transmissions, or are you on a completely different level?
No, I'm looking to network sessions, and so every session is a case. And I want to predict when I have listened enough to the protocol to understand it. So every time I add a case, there are more transactions or transitions, or even more activities. So, yeah.
Yeah, I think there should be a way to calculate something with that. Yes. Maybe Will is yes.
So if I may try to help Anne a bit. In fact, Anne in her PhD did research into minimal to description length analysis, where you can see how compactly you can encode things given a model. But to come to your question, if you look at the 4 dimensions of a log versus a process model, there is fitness. Does the behavior that you see fit into the model? There is precision. Doesn't the model allow for all kinds of things that you don't see in reality? Simplicity. If there is a simple model, you take the simple model rather than the complicated model. But I think the metric that you refer to is generalization. Like, is my model already general enough to be able to explain things that you did not see yet? And kind of in research, there are some metrics to quantify that. But these metrics are a bit difficult because they are reasoning about an unseen future. And that makes it difficult. So there is work in that area, but yeah, it's not as solid, I would say, as the work in the other 3 dimensions.
Thank you.
Any more questions? Yeah. Oh yeah, you had one.
The slide you had about you may not see the whole picture. I think that's very important because, and I'm going to go to a question quickly, because sometimes we're analyzing a process and the data doesn't tell us everything. Sometimes there are things people do that are not in the data, but they're done and are very important in certain processes. My question is, in your experience, how do you go about capturing what people actually do that may not be represented by data, and in the improve phase, then you start capturing, because the problem there is that people do a lot of things, but what they do that is not captured should be now captured. There may be many things they do, but which of the things they do should now be captured in data, and also the case where you have data that is being captured that is not really needed. You want to lean your streamlined process. I would like to ask you, what is your experience about these 2 things?
Yes, thank you. Well, so my experience, it's not necessarily the case that you have to start trying to capture everything in the data upfront, before knowing what you need to do. But that the key aspect in the analysis is that while doing the process analysis, you need to get into contact with those people working in the process. That can be done in some kind of interactive workshop session, or working together with the key stakeholder who knows that process. Because then once you come up with certain patterns or certain problems in the process, for example, a very simple and obvious example is if you compare, teams, and different teams have different average, times. How long do they take to finish a certain, incident? We had the incident example before. Well, if one team is slower than the other one, the simple reason may be that they get the difficult cases. And you may not have that particular aspect in the data, but once you start bringing up such, observations, but don't do it in a way that you present it in the final way, like that's, and that's my verdict, but rather than as an observation, look, this is what I'm seeing. Can you clarify, do you have an explanation for that? The business people, the people working in that process, they know, and they can help you make that context complete, or maybe you then go through a second iteration and you say, well, we have to capture that specific aspect in the data as well, but it's not always necessary like that. Okay, one more, yes?
Yeah, I have one small question. These metrics, do you plan to implement some of that in Disco, or is it suggestions for us what we can do?
Yes, I'll repeat the question. So Willy asked whether those are questions that we implement or want to implement in Disco. Well, some of them are already there. Some of them you can get easily. The thing is that people are measuring quite different things. So it's also not. Please don't think that's the final and complete set of cross-mining metrics. Far from it, right? These are some of the examples that we have seen, and we keep looking for what people are analyzing and how that can be supported in the best possible way. But I think the most important thing is for yourself think about, well, what's the thing that I want to measure? And with the generic cross-mining tool, you can quite simply and quickly measure the particular aspect you're interested in.